Have you ever questioned the nature of your reality? Imagine a world meticulously crafted, a digital tapestry woven with intricate code, where every sunrise, every laugh, every fleeting thought is but a calculated simulation. This is the essence of the simulation hypothesis, a mind-bending idea that proposes our reality is not fundamental, but rather a sophisticated computer program run by a more advanced civilization. It's a concept that has captivated philosophers, scientists, and science fiction enthusiasts alike, blurring the lines between the tangible and the virtual. The simulation hypothesis is not merely a product of imaginative minds. It has its roots in scientific discourse. The ever-increasing power of our own technologies, particularly in the realm of virtual reality, fuels this intriguing possibility. As we create increasingly immersive digital worlds, the question arises, could we ourselves be living within such a construct, oblivious to its artificial nature? This unsettling thought experiment challenges our understanding of existence, prompting us to examine the very fabric of our perceived reality. The allure of the simulation hypothesis lies in its ability to explain some of the universe's most perplexing enigmas. Quantum mechanics, with its probabilistic nature and counterintuitive principles, seems to suggest that reality is not as concrete as we once believed. The vastness of the cosmos, teeming with billions of galaxies, each harboring billions of stars, hints at the possibility of civilizations far more advanced than our own, capable of feats we can scarcely comprehend. Could one of these civilizations have reached a technological zenith, mastering the art of simulating entire universes? The possibility, however remote, is tantalizing. It forces us to confront our assumptions about the nature of existence, urging us to consider that what we perceive as real may be but a carefully constructed illusion. This is not to say that our experiences, our emotions, our relationships are any less meaningful. But it does cast them in a new light, adding a layer of complexity to our understanding of the self and the universe we inhabit.
The simulation hypothesis finds fertile ground in the realm of theoretical physics. Quantum mechanics, with its probabilistic nature and the observer effect, suggests that reality is not fixed, but rather fluid, shaped by the act of observation. This aligns with the idea of a simulated reality, where the observer's interaction with the program could influence the unfolding of events. Could the seemingly random nature of quantum events be a result of the underlying code of the simulation? Further fueling the hypothesis is the concept of computational irreducibility, proposed by Stephen Wolfram. This principle suggests that certain complex systems cannot be predicted by shortcuts. They must be simulated step by step to determine their outcome. If our universe operates on similar principles, it could imply that a vast computational power is required to simulate its evolution, hinting at the possibility of a hyper-advanced civilization running the program. The search for evidence of the simulation hypothesis extends beyond theoretical frameworks. Some scientists propose looking for telltale signs within our own reality, subtle glitches or anomalies that might betray the artificial nature of our universe. These could manifest as unexpected deviations in physical laws, inconsistencies in the cosmic microwave background radiation, or even seemingly impossible events that defy our understanding of causality. While such evidence remains elusive, the search itself underscores the scientific community's growing interest in the simulation hypothesis. It's a testament to the idea's power to spark debate and push the boundaries of scientific inquiry. The quest to unravel the true nature of reality, whether simulated or not, continues to drive our exploration of the universe and our place within it.
Our current technological capabilities, while impressive, pale in comparison to the computational power required to simulate an entire universe, creating a reality as vast and complex as ours. With its intricate web of physical laws, its countless interacting particles, and its emergent phenomena like life and consciousness, would necessitate computational resources beyond our current comprehension. This limitation, however, doesn't invalidate the simulation hypothesis. It merely highlights the potential gap between our current technological prowess and that of a hypothetical advanced civilization capable of such a feat. Consider the exponential growth of computing power over the past few decades. Moore's law, while showing signs of slowing down, has demonstrated the remarkable pace of technological advancement. If this trend continues, even in a modified form, it's conceivable that future civilizations could achieve computational capabilities that dwarf our own, making the simulation of a universe a less daunting prospect. The development of quantum computing adds another layer of intrigue to this technological trajectory. Quantum computers leverage the principles of quantum mechanics to perform calculations far beyond the reach of classical computers. This nascent technology holds the potential to revolutionize fields like medicine, materials science, and artificial intelligence, and could one day provide the computational power needed to create highly realistic simulations. However, even with such advancements, simulating a universe as complex as ours presents significant challenges. The sheer amount of information required to represent every particle, every interaction, every nuance of our reality is staggering. Moreover, replicating the emergent properties of our universe, such as consciousness, remains a profound mystery. Bridging this technological gap requires not only computational power, but also a deep understanding of the fundamental principles governing our reality.
The simulation hypothesis is not solely a scientific inquiry, it delves into the realm of philosophy, raising profound questions about the nature of reality, consciousness, and free will. It echoes the ancient allegory of Plato's cave, where prisoners mistake shadows on a wall for reality, unaware of the true world outside. Are we, like the prisoners in the cave, mistaking the simulated reality for the fundamental one? If we are indeed living in a simulation, what does it mean for our understanding of self? Are our thoughts, emotions, and experiences truly our own, or are they merely programmed responses within the simulation? This question challenges our notion of free will, suggesting that our choices may be predetermined by the simulation's code. The concept of purpose also comes into question. If our reality is a simulation, what is its purpose? Is it merely a grand experiment, a form of entertainment for the creators, or does it serve a deeper, more profound function? The possibility of a simulated reality forces us to confront existential questions that have plagued philosophers for centuries, adding a new dimension to our search for meaning and understanding. Despite the unsettling implications, the simulation hypothesis also offers a sense of liberation. If our reality is not fundamental, it opens up the possibility of transcending its limitations. Could we one day hack the simulation, manipulate its code, or even escape into the true reality beyond? This prospect, while speculative, fuels our imagination and encourages us to explore the boundaries of what we consider possible.
The simulation hypothesis finds intriguing parallels in the realm of quantum information theory. This field explores the nature of information at the quantum level, suggesting that information, rather than matter or energy, might be the fundamental building block of reality. This aligns with the idea of a simulated universe, where information encoded in the simulation's program dictates the behavior of everything within it. The holographic principle, a concept arising from string theory, further strengthens this connection. It proposes that the information content of a three-dimensional space can be encoded on its two-dimensional boundary, much like a hologram. This suggests that our three-dimensional reality could be a projection of information stored on a distant surface, hinting at the possibility of a simulated universe encoded on a vast computational substrate. Quantum entanglement, another perplexing phenomenon, adds to the intrigue. Entangled particles exhibit a spooky connection, influencing each other instantaneously regardless of distance. This seemingly faster-than-light communication could be explained if the entangled particles are merely different aspects of the same underlying information within the simulation's code. These connections between the simulation hypothesis and quantum information theory suggest that our understanding of reality is still in its infancy. As we delve deeper into the quantum realm, we may uncover further evidence that information plays a more fundamental role than we previously imagined, lending credence to the idea that our universe could be a product of sophisticated information processing.
If our reality is a simulation, it begs the question, Who are the simulators? The simulation hypothesis doesn't offer concrete answers, but it opens up a realm of fascinating possibilities. The simulators could be a highly advanced extraterrestrial civilization, capable of harnessing computational power on a cosmic scale to create simulated universes. They could be conducting grand experiments, exploring different physical laws and initial conditions, or simply seeking entertainment through the observation of simulated life. The concept of nested simulations adds another layer of complexity. If we can conceive of simulating a universe, it's conceivable that our simulators are themselves simulated beings, part of a higher-level simulation. This could lead to a hierarchy of simulations, each nested within another, forming a chain of realities that extends beyond our comprehension. The implications of such a hierarchy are profound. It suggests that the ultimate nature of reality may be far removed from our current understanding, hidden behind layers of simulated existence. It also raises the question of whether there is a base reality, a fundamental level of existence that underpins the entire hierarchy of simulations. The search for the simulators, while seemingly impossible, could provide clues about the nature of our own reality. By studying the limits of our own computational capabilities and exploring the frontiers of theoretical physics, we may gain insights into the technologies and principles that would be required to create a simulated universe, potentially shedding light on the capabilities of our hypothetical creators.
If our reality is a simulation, the question of purpose looms large. Why would a civilization with such advanced technological capabilities go through the effort of creating a simulated universe? The answer, elusive as it may be, could lie in the nature of the simulation itself. One possibility is that the simulation serves as a grand experiment. The simulators could be exploring different physical laws, testing the limits of possibility, or observing the emergence of complex phenomena like life and consciousness. Our universe, with its intricate laws and its diverse array of particles and forces, could be one of many simulated universes, each with its own unique set of parameters. Another possibility is that the simulation is a form of entertainment. The simulators could be deriving pleasure from observing the unfolding of events within the simulation, much like we enjoy watching movies or playing video games. The challenges, triumphs, and tragedies of simulated life could provide a source of amusement or intrigue for the creators. A more profound possibility is that the simulation serves a deeper purpose, one that transcends our current understanding. It could be a form of education, a way for the simulators to learn about themselves or the universe they inhabit. It could be a means of preserving their history, culture, or consciousness, ensuring their legacy endures, even if their physical forms cease to exist. Decoding the simulation's intent, while a daunting task, could provide valuable insights into the nature of our own existence. By studying the patterns and anomalies within our reality, we may uncover clues about the simulator's motivations, shedding light on the grand design behind our simulated universe.
The simulation hypothesis challenges our understanding of free will, a concept central to our sense of self and our moral compass. If our reality is predetermined by the simulation's code, are our choices truly our own, or are we merely puppets dancing to the tune of the program? This question leads to a philosophical quandary. If our actions are predetermined, how can we be held accountable for our choices? Does the concept of morality hold any weight in a simulated reality where free will is an illusion? However, the absence of absolute free will doesn't necessarily negate the significance of our choices. Even within the confines of a simulated reality, our decisions shape our experiences and influence the unfolding of events within the simulation. The choices we make, whether predetermined or not, define our individual narratives and contribute to the tapestry of the simulated universe. Moreover, the very act of questioning our free will demonstrates a level of consciousness and self-awareness that transcends the limitations of the simulation's code. It suggests that even within a deterministic system, the capacity for reflection and introspection can emerge, adding a layer of complexity to the question of choice and agency. The paradox of free will in a simulated reality highlights the intricate interplay between determinism and agency. While our choices may be constrained by the underlying code, our capacity for self-awareness and our ability to make decisions, however predetermined, shape our experiences and contribute to the richness of the simulated world.
The possibility of escaping the simulation, while speculative and bordering on science fiction, captures the imagination and fuels our desire to transcend the limitations of our perceived reality. If our universe is indeed a sophisticated computer program, could we one day find a way to manipulate its code, hack the system, and break free from its confines? The prospect of escaping the simulation raises a host of questions. What would lie beyond the simulated reality? Would it be a more fundamental level of existence, a realm governed by different physical laws, or perhaps the domain of the simulators themselves? The act of escaping the simulation would require not only a deep understanding of the simulation's code, but also the ability to manipulate it. This would necessitate technological capabilities far beyond our current comprehension, potentially involving the harnessing of quantum phenomena or the manipulation of spacetime itself. However, even if we were to achieve such technological prowess, the ethical implications of escaping the simulation are profound. Would we be disrupting the simulator's experiment, interfering with their creation, or potentially harming the simulated beings within the system? The question of escaping the simulation highlights the tension between our desire for knowledge and our responsibility to respect the boundaries of our existence, whether simulated or not. It underscores the importance of approaching such possibilities with caution and a deep understanding of the potential consequences.
The simulation hypothesis, while lacking definitive proof, remains a powerful thought experiment, challenging our assumptions about reality and pushing the boundaries of scientific and philosophical inquiry. It forces us to confront the limits of our knowledge and embrace the possibility that our understanding of the universe is far from complete. The true nature of our reality, whether simulated or not, may forever remain an enigma. The quest to unravel this mystery, however, is a testament to our innate curiosity and our relentless pursuit of knowledge. It is through this pursuit that we expand our understanding of the universe and our place within it. The simulation hypothesis serves as a reminder that our perception of reality is subjective and limited. It encourages us to question our assumptions, explore alternative perspectives, and embrace the unknown. It is in this spirit of intellectual humility and open-mindedness that we can continue to explore the mysteries of the cosmos and strive to unravel the true nature of our existence. The possibility of a simulated reality, while unsettling, also offers a sense of wonder and awe. It suggests that our universe, with all its complexity and beauty, could be a product of a profound intelligence, a testament to the creative potential of consciousness itself. Whether we are simulated beings or not, the very act of contemplating this possibility expands our horizons and enriches our understanding of the vast and mysterious universe we inhabit. Did this video glitch you out? Let us know in the comments if you think we're living in a simulation. Don't forget to like and subscribe to SciSips for more mind-bending dives into the cosmos.